Hi everyone, there was a request for a video on the lot ordering problems. Okay, so first we're going to start with, in general, when we're doing our business, we're usually trying to minimize our costs here. And so our total cost equation is storage costs plus production costs. Okay, and then if we read the problem, so we have a restaurant has an annual demand for 900 bottles of wine. It costs $1 to store one bottle for 1 year, and it costs $5 to place a reorder. Find the optimum number of bottles per order. Okay. To minimize the cost, right? So our X variable, we're going to choose the number of bottles per order, right? Number of bottles of wine. Okay. Now we're going to start trying to calculate that storage cost and that production cost. So if X is our number of bottles of wine, on average, we are going to store half of them, right? Our cost, it said, was $1 per bottle. So this is $1 times X over 2. Okay. So you can either write it as 1/2 X or just X over 2. It's up to you. Next up, we have our production costs. Okay. And production costs has two pieces to it. You have the cost per order or per batch. So we have cost per order times the number of orders. Okay, so we have two pieces to a production cost. And now the number of orders we can write kind of nicely. So if we need 900 bottles of wine for a year, and we have X in each order, then our number of orders would just be 900 over X. Cost per order is a little different. So it says it costs $5 to place a reorder. So that would be 5 plus, and now they didn't tell us how much a bottle of wine costs. I'm just going to label that anything that you think, right? Let's say it costs $12. I'm making up a number. You can make up any number you want, and I'll show you why in a minute. So 12x. Okay, so now when I multiply those together, I get 5 times 900, which would be 4,500 over x, plus 12 times 9 would be 108. Okay, and the x's would cancel. And so the reason why the actual price of the bottle of wine doesn't matter is that when we have a constant and we're going to optimize it, which means we're taking the derivative, it becomes a 0 anyway. So the number itself does not affect what the optimum number of bottles is, right? So that cost per bottle does not affect your optimum number. Okay, so I'm going to write my total cost now. Total cost is storage costs plus this production costs. And then in order to optimize it, right, to minimize or maximize, we take a derivative. So we would get 1/2 plus, and then this -1 would come down, so negative 4,500, and then it would become a -2 power, which is over an x squared. Now in order to solve for that min or max, we would set it equal to 0. Okay, so I would have 1/2 equals 4,500 over x squared by adding it to the other side. Okay, which would then give me x squared equals 9,000. And then we would take a square root of each side. And I got 94.87. Now I can't really have 0.87 of a wine bottle. Okay, so you're going to kind of have to look at the numbers surrounding it. So 94 and 95. And if I plug these into the cost, okay, I can see which one has a lower overall cost. The other thing I want to do is make sure that this is in fact a minimum and not a maximum. So I'm making a little number line just to finish this up. TC prime 94.87. I'll go ahead and test 1 and 100, just trying to pick some sort of easy numbers. So I get 1/2 plus 4,500, that's definitely, sorry, 1/2 minus 4,500 is definitely a negative number. 1/2 minus 4,500 over 100 squared is in fact positive. So I'm going down and then up, which means it is in fact the minimum point. Okay. So our last check, just to make sure it's actually an optimum, is just to check the 94 versus 95. So 2 choices, 94 and 95. And putting them into the total cost. So if I plug 94 in to my x over 2 plus 4,500 over x plus my constant, I get 10894, so 10,000. So I'm just going to write it down there, 10894.87. And that is in dollars. Now I'm going to try 95, stored as my x value. I got 10894, still also 0.87. Right, so in this case, both of the costs came out very similar. If you look at the non-rounded numbers, 95 is slightly better. Okay, so we're going to use our kind of correct mathematical rounding and choose 95 for our answer. And so to answer the question, find the optimum number of bottles per order. Make sure you answer it. 95 bottles of wine per order. If you have any questions, feel free to ask. Thanks, everyone.